relational model, and we'll discuss more on that. So let me share my machine. So are you able to see my screen, everyone?
Yes, Steven, I can
Yes.
see.
Yeah, okay.
Steven, it is being recorded, right?
Yes, it is being recorded. So today we will do the hands-on on relational model. This is a relation model use case. It is a retail banking, say a simple retail banking, say SBI or any other bank. Okay, where we have these other requirements. Okay, and we need to create a data model out of it, and which will be a relational data model. Okay, that means entities, attributes, and the relationship. Okay, so what are the requirement of this retail banking? So it is the first requirement is bank offers a savings and current account. Very easy requirement, savings and current account. Second is bank has multiple branches. So SBI has multiple branches. Okay. Each branch has a branch manager for each bank. Okay. If there is a bank and there is a branch manager, okay, who is the head of that branch. Okay, branch manager. Each employee a bank has a supervisor. Okay. May I 1 second, maybe somebody join. Let me check that one. No. Okay. So next question was each employee of the bank has a supervisor. So in the bank branch, we have many employee. Like yes, yes, please. Okay. So a customer can open a multiple account. So whenever a customer goes to the bank and he can open a multiple account, like he can open a 2 savings account, 1 current account, like that. Okay. So what customer can do? Customer can deposit or withdraw, or that is called transaction, either deposit, withdraw, or cash from the account. Okay. And an account is always open a specific branch. Whenever a customer opens a account, it should be open in any specific branch. So SBI is having so many branches. So account is being open in one of that branch. Okay, say SBI Kolkata branch. Okay, so that branch should be only one branch. Okay, an account is always linked to one branch. Okay, so this is a requirement. Okay, so from here we need to create a data model. What is our first step? You remember, first step was, let me change the color of the pen. First step is our conceptual model. Okay, guys. First step was our conceptual model. Conceptual model. Okay. Then second step is what? Second step is logical model. Okay. And third step is physical model. Physical model. So what we need to do in conceptual model? Conceptual model, what we learned is that it contains only the entities in broader sense and the relationship between those entities. Here in retail banking, we need to find out the probable entities, okay, and then probable relationship each those two entities have, okay. So here, let's start with identifying the entities. The first step is to identify the entities. From this requirement, we can see bank is one of the entities. Okay, just highlight that. Bank is one of the entities. Okay. Second one is account. Okay. Then third one is branch. Fourth one is branch manager. Then fifth one is employee. Then supervisor. Then customer. Multiple accounts on customer. Transaction. Okay. How many and any other specific? No. So we can see we have identified so many entities. One is bank account. Number one is bank, then account, then branches, then branch manager, then employee, then supervisor, customer, and last one is transaction. So eight uh, entities has been identified. For conceptual data model, we can use use either simple Excel, okay, or any other tool like Draw.io or like that, Draw.io, okay. We will not use any data modeling tool because data modeling tool does not support this conceptual data model. They support these two only, okay. But what we do in Arwin, instead of creating any attributes, we create only the entities and the relationship. Then it's become some kind of conceptual model. But better, since we are dealing conceptual data model with business, use any Draw.io or Excel or like PowerPoint, okay, or say diagram. There are many tools which will give you a pictorial representation of conceptual model. Okay. So let's start with this conceptual model, okay, and probable relationship. So we will use what we will use. Mm, let's use Draw.io. Draw. Draw.io. So in Draw.io, we'll go for entity relationship diagram, okay, and create. Remove all this, okay. Okay. Now let's create the entities first. Okay. First one is bank. Okay. Let's go here and create an entity. Say blank entity like where is entity? Create one entity. So we have eight entities. So we'll create eight entities. Like one, copy paste, just copy and paste it. 2, 3, 4, 5, 6, 7, 8. Okay. Now give the name of each entity. Like first give here bank. Okay. Then what we have? Account. Then branches.
Branch. Just I'm just saying here.
Yeah. Okay.
Branch.
Then
Branch manager.
okay. Branch manager. Thank you.
Employee.
Supervisor.
Yeah. Customer supervisor.
Customer.
And last is transaction. We have 9 boxes there. Yeah. One we have to remove.
1, 2, 3, 4, 5, 6, 7. Okay. Okay. So we have created the uh, all the entities. Okay. In conceptual data model, what we do. So let me write here. Sure. Data model. Okay. So here we will create a probable relationship. Okay. With the entities. Let me make a branch manager, supervisor, account will come down. It will be created to branch manager, customer transaction. Okay. Okay. Now see how bank is related to branch. So it is one to many, correct? One branch can have many branches. So we'll create some one to many relationship. Okay. Bank and branch. One to many relationship. Okay. So a bank mandatory. So why I have written mandatory relationship? A bank should have at least one branch. Okay. Otherwise, if it is a smallest bank, then also it have only one branch. Okay. One or more branches. Okay. Now, the relationship between branch and branch manager, each branch should have a, so each branch should have a branch manager. Okay.
One to one.
One or more branch manager. Anybody can join. 1 second.
Is it 1 to 1 or just
1 second, please. Let me admit. Okay. So yes. So branch and branch manager relation is one branch can have many branch managers, but one branch manager only associated with one branch only, right? Say for SBI Pune branch, that branch has a branch manager. Means say Firoz is the branch manager of that SBI Pune. So only that means Firoz is only associated with that SBI Pune. He is not associated with SBI Mumbai. Okay. So branch manager is associated with only one branch, but a branch has many branch managers. Say, for example, from 1st January to 30th June, there is a branch manager is Buddho. Then from 1st July, it is Mahmood. That in that way, it can have many branch managers. So relation is is a branch should have one or many branch managers. Okay, it cannot be vacant. Okay, again, it is a one to many relationship. One to many. Okay.
I have a question.
Yes, please.
So at a time,
Hmm.
there will be always one branch will have one branch manager, right?
Correct.
So why don't we have one to one?
Yes. And just like I said, I want to uh, get the information of earlier branch manager as well. Okay. Historical records. Okay. Because uh, we can sometimes it might happen that we need to get say one branch manager has sanctioned a loan, okay, or something, and then next branch manager came and he doesn't know who signed that. Okay, so if we can have a branch historical date of other branch managers, then it is better to have a relationship like uh, historical relationship, right? So that's for that reason we can have many relationship, one to many. Okay, otherwise it is one to one. You are correct, but we if we
But
need
that's-
to
but
take
but
historical, yeah.
but but suppose Buddho is now the branch manager,
Hmm.
but in future that branch can have another manager, right?
Yes.
But that manager can go to some other branch.
Yes, yeah, we can that manager can go to other branch, but for that branch, we should know who was the branch manager for which period. Okay, to get the more okay. If I will show you why it will become a while we do the logical model, we'll show why we need one to many. Let me open one Excel first. Let me try to explain. Okay. Okay. Say this is a branch manager table. Let me what we have in the column, first one is say branch manager ID. Branch manager ID. Okay. Then what we'll have? Uh, say employee ID because branch manager is also an employee. Okay. We have an employee ID. Then branch code for which branch this employee belongs to. Say branch code CD. As of now, I read CD. Then start date and end date. Okay. So let me so this is a branch manager, typically a branch manager table. Okay, we have these columns, this many columns. Okay. Now let me enter branch manager. Say branch manager one, say 1001 ID, whose employee ID is say 123456. Okay. He is in branch 23, branch code. Start date say 1st of January 2024. Okay. He is the latest branch manager for branch code 23. Okay. Now this branch man this employee got promoted and he transferred from this branch code to another branch code. Okay, so that branch manager table say now say employee ID 123456 So 8, 9 become a branch manager whose branch manager ID is 102 from same branch, say 23, and this guy, say 23rd of July 2024, he left. So from next day onward, this guy become a branch manager. Okay. Until now, he is a branch manager. If, as Mahmood, as per um, your question, if we do not have this one, if it is 1 to 1, then will not have this one, right? We'll have only what happened? What delete? We will have only this one. Okay. Then somebody say an account is being opened on say 1st May. Okay. 2024. Then how will understand uh, who has because whenever a account is being opened in a branch, then branch manager has to sign something, right? So in document. So I cannot find which manager has signed that document, right? So for that we need the branch manager historical information of that branch managers in a particular branch. Typically, if you go inside a branch, in the branch manager's chamber, you will find one big board where it was written that from this days to this day, this is the branch manager. His name is written there. Similarly, with you will find some board. Typically, have you seen that kind of board in any branch manager chamber, Mahmood or anybody? Because
Yes, yes.
yeah, because
Yeah.
this is because we need to know who was a branch manager in that branch at a particular period of time. That's why we are keeping branch as a means it is one to many. Okay. Moreover, suppose this employee, this 001, sorry, this employee now move to another branch. Say branch is now his new branch, his new ID, branch manager ID become 4 or 3, and he moves to any another branch, which is branch code is 26 from 24th, say on 24th. Okay. So from this table, we can also find out an employee who is a branch manager moves between one or more branches. Okay. Here also we can find it out. Branch manager table. Okay. So that's why from branch to branch manager, it is one to many. Okay. Again, similarly, I can have a relationship between employee and branch manager is a one to many because from this table again, see, you can see uh, an employee more than one, say for a particular branch. Let me delete this one. This branch 23 code, we have more than one employee as a branch manager, correct? So here also the relationship will be one to many between employee and branch manager because each branch manager is an employee, but one employee can become more than one employee can become a branch manager. So here also we'll have one to many relationship. Okay. Now employee and supervisor. Here employee and supervisor is a recursive relationship. Okay. Recursive relationship is what? Recursive relationship is the relations where same entity is being related to itself. Okay. If I remove, I can easily remove. Say I have removed this one. Don't uh, consider this one. Then how I can create an employee and supervisor? How I can create? I can create with self join, right? Like this recursive join. because in employee who becomes supervisor is also an employee, correct? So we can create like this. But again, the issue will come when there is a historical information we required. Okay. Because similarly in branch, same way, an employee can have many supervisor during his tenure of his career tenure, right? And similarly, a supervisor can have many employees under his name. So this many to many cardinality creates the self join difficult. That's why we create a separate supervisor entity where we give a relationship as a what, as one to many relationship. Okay, let me create one to many relationship. Okay, so our employee can have many supervisors where supervisors have like start date, end date, and so on. So employee one supervisor is say 5, start is so something to something. Then again same employee can have another supervisor whose ID is 6 from starting from this date. So to create the relationship of a employee with a supervisor and preserve the history, we create a one to many relationship, and we remove this self recursive join. Okay, here we'll have two joins. Okay, why two joins? One is employee to supervisor join, and second one, supervisor ID is nothing but an employee ID. Correct? Because supervisor is on also employee. Okay, let me show you in the. Please ask me if you have any questions, Mahmood or Buddha.
Even like one quick question over here. So, uh, isn't it in the purpose of transactional? If you are trying to create any kind of relationship over here, so isn't it more feasible if making it an employee table where we gonna create a column like supervisor and keep it as yes or no, true, yes or no, kind of like you said, recursive, right? So if we are gonna make it like historical, isn't it more gonna be on side of analytics kind of, or shouldn't we go towards the analytics when we are maintaining the historical data or
See,
something
okay,
like a,
okay,
yeah, because this is a small data, right? But we can keep it in transaction, but if it is like going to make get some load onto the database, then how how we gonna decide it? Like that's my
okay.
question.
In typical, if you say means transactional data, it is not a transactional data. First of all, transaction, and it is not will be not be a very big table. What you are saying for analytics purpose, it will be a transactional record like some measures which will be loaded in fact. Okay, fact table. You will discuss in the next chapter. Okay, when we'll discuss dimensional model, load is on fact table, not on dimension tables. Okay, so here historical information is being maintained because to gather the information. I am not creating the historical information on transaction tables. Okay, I am making the historical information on some particular supervisors or like branch manager to gather the information who is the particular supervisor or for an employee on a particular time. Because see here in branch manager, if I do not have the historical information, I just right now I said, if we wants to issue some say NOC or kind of that, then we need to check who was the supervisor during the time that loan was being granted. Okay, so that's why we need the branch manager as a we need to preserve the some historical information. Okay, and for supervisor also same here, we need to create some sort of history because other means we need to know who is the supervisor of that employee in a particular period of time. Otherwise, say for say appraisals or some other things, we need to get back to that supervisor for feedbacks. Okay, that's why we are creating some historic means preserve some historical data. Okay, records. It is not becoming your analytical. This is a relational model. Relational model doesn't mean that you will have a only the latest record. Okay, that is a OLTP system. Okay, which you are saying about that. That is a OLTP. Don't confuse with OLTP with relational model. Yes, OLTP is a relational data model, but all data model all relational data model are not OLTP system. Okay.
Yeah, that's what made me. I'm just thinking about OLTP, how web application gets connected. Maybe that's what made me confused over here.
And
Yeah, don't get confused. OLTP is the latest transaction snapshot kind of database where you have only 1 or 2 days record. Okay, but relational model is means any relation table. Say I last day I have shown you some relational model I have created. I have means reverse engineering and create one relational model. You remember that adventure work which
Yes,
is
yes.
so that there we can have a lot of records, right? A lot of relation tables where we have lot of records, historical record, current record, everything. In typical data warehouse relational database where you have say Oracle relational database, you have a lot of records. It doesn't mean that it will have only the current record. Okay, all the CRMs to all the sorry, not the transaction system, POS or point of sales, those OLTP system has only 1 or 2 days record. Okay, don't get confused. We are creating a data warehouse. If we do not have the
Yeah,
historical record, how what is the advantage of data warehouse?
yeah.
yeah,
I
and
got
to
that.
in one since you brought up this point, so like typically we have how we place the order in Amazon, right? So
Mhm.
we have one orders table, right, where the order status is. If you have submitted the order, the status will be submitted. Then this status will move from submitted to pending, then to final delivered. So these are all are the events which are going change at a different point in time. So they there we maintain the history. Like I think that's the typical example we can.
Yes, they are creating the history. It is as per your requirement. How that in that table, say order table, there is a status, okay,
Yes.
which is getting changed
Yes.
accordingly where that order lies. Okay,
Yeah.
so that doesn't mean that it is we cannot preserve the history. Okay,
And based on the order date, like we see multiple statuses are there, so which one to pick it, like that's what we can make it, like we pick the latest order which is the status, so that's how we take it. And with relation to this branch manager and supervisor, and I think Tuhin, there may be a typical scenario where the employee supervisor can get changed, right? Like we how we
Yes,
work
yes, same.
move to
Yes,
the project.
similarly.
Yeah,
Yeah, I said that. I have already said this.
yeah,
See,
yeah,
employee one has a supervisor whose employee ID is 6 from 1st January to say 30th June. Okay, then his supervisor get changed to say another the employee ID 7. Typically in our organization also, if we our supervisor get changed means in some time, right? From say currently I am your supervisor. Maybe in few times Mahmood become your supervisor, right, Farhan? So it is a supervisor is get changed whenever we change the project. We change means there's organization some reshuffling is done. Supervisor get changed. Okay, so that's why we have one to many relationship in employee to supervisor. Also, there is one what I was giving the example. I forget. I will come back here once I remember. Don't worry. Okay, I actually forget what I'm going to say you. Okay. Now, there is a two relationship between employee and supervisor. One is employee with a supervisor, okay, and another one is supervisor with employee because supervisor is also an employee, correct? So there is a two relationship between whenever there is a recursive relation, you have to we in conceptual data model we have to create two relationship. One is employee with the supervisor, and another one is a supervisor with employee. Okay, so okay, now I remember. So for example, we have a supervisor ID, say supervisor ID. Okay, then we have employee ID. I'm writing in short form. Then start date and end date. Okay. Supervisor ID, we have an employee table. Let me create one employee table as well. Otherwise, you will not understand. In employee table, we have employee ID, then employee name. Okay. Say salary, then gender. And we have a department ID as well. Okay. Now employee ID 1001, then 1002, 3, 4, 5. 1, 2. Okay. In this way, we have say 7 employees. Name is a Buddha, then Fahad, then Mahmood, then Firoz, then we have Vishwa, then we have Amit, and say Syam. These are the employee whose salary depends, say, like this. Anything random salary I'm giving. Oh, why negative? Okay, leave it. All are male. Let me one female. See Rekha. Male, male. Make it a female. Okay, department say 1, 1, 2, 3, 4, 5, 2, like this. Okay, so this is my employee table. Okay, try to understand why there is a two relationship here. Okay. Now, say supervisor ID, supervisor, say employee. This top boss is Buddha. Buddha is the CEO of that company. Huh? So similarly, we talk about hierarchical last day, where one is top, then we have some hierarchy, then some hierarchy like that. So Buddha is the top, so he doesn't have any supervisor. So but this Farad is the second boss, so CEO, then CFO. So he reports to Buddhadev. Okay. Then we have Mahmood, who is report to Farad. Okay. And Firoz is also report to so it is 1002. Okay. Firoz is also report to 1002, my supervisor. And then Vishwa report to say Mahmood 1003. Then Rekha reports to Mahmood and Syam reports to Farad. Okay. No, Mahmood. More guys, Syam. Say
1002.
1002. Okay. Yeah. So this is latest supervisor and he is the boss, so he doesn't have any, he reports to himself, so no supervisor. Now, for supervisor, this is my supervisor ID. Okay. Current supervisor ID, say supervisor ID. Okay. Now, here in supervisor table, we have say for each employee who is the supervisor. So here for 1002, my supervisor is 1001. Okay. Let me copy this one. And for 1003, who is the supervisor? 1002. Then again 1004, who is my supervisor? 1002. Let me complete this one, then I will explain you. I am leaving Buddha because he is a boss. Okay. Now in supervisor table, this is my uh, typical supervisor table where we have some supervisor ID and the employee ID. Now this supervisor ID is also an employee ID. This ID which I have created 1001. If I go into the employee table, and we can easily find out who is the supervisor, name of the supervisor, other details like email IDs, phone number. Okay. So if we join these two tables, we can either join with supervisor ID with employee ID or employee ID with employee ID. Correct? That's why we are having two two relationship with employee with supervisor. One is for this one, for this employee tables, because one supervisor can have many employees, right? The relationship that like employee 01 is this who is having more this one. Say 102 has, he is a supervisor for these two people, 1003 and 1004. Okay, so we created this one to many. Again, a supervisor is also an employee, right? This is also an employee. Okay. Then there is also one more relationship with employee and supervisor. Okay. Similar relation. Let me clear. Well gone. Okay. One is for employee and employee with employee table, and one is supervisor ID with a employee table. That's why we have a two relationship. Have you get me? Have you got me? Okay.
Yes, please.
Okay. So when we go for logical model, we'll see more in more detail. Okay. As of now, this is a relationship. We are creating the conceptual model. Then we have a relationship between these three: account, customer, and transaction. So there's a requirement. I remember the requirement was that an account is being opened in a particular branch, specific branch. So there is a relationship between account and branch. Account is related to only one branch, but branch can have many accounts. Okay. So there is a relationship like this, one to many, or mandatory one, when an account is open to any particular branch, and branch can have many accounts. Okay, so one to many. Then a customer can open a account. So customer and account is relation is customer can open a multiple accounts. An account belongs to one customer, right? Anyone uh, who open a account can have a customer name. Okay, so there is a relationship between customer and account. Is a customer can open a multiple accounts, so it is one to many again. Okay. Okay. Now transaction. Okay. So a transaction is always happen via a what? Via an account. And who create a transaction? Transaction is being created by a customer. Correct. So a customer can create many transactions. Okay, and an account can also have a many transactions, right? Our account can, in an account, we can withdraw cash. Say each day we are withdrawing cash, or deposit on same day we deposit cash and withdraw cash. So we have a many transactions. Again, the relationship is oh, क्या हुआ? Why I have created this this 1 to 0? Because account can create, may have transaction or may not have transaction. That's why it is 0. Okay, 0, 1 or many. Okay. Similarly, customer can either do a transaction or may not do a transaction. Means 1, 0, 1 or many. Okay. Now this is a relationship. Okay. This is a conceptual model. So you can write like this also. Since you are giving this to uh, business, so you may create some you can write like this: branch has many branches. Okay, like this. Okay, an employee has a supervisor. Has supervisor. A supervisor here in this relationship, you can write a supervisor is an employee. So from here, so employee has supervisor, and supervisor is also an employee. Employee and branch manager. Branch manager is an employee. Again, here the relation will be is an employee. Here you can write branch manager and branch relations is the branch manager. Each branch has a branch manager. Okay. Account to customer. An account is being opened by a customer. Is being opened by. Is opened by. What? Open by. Customer can make a transaction. Can make a transaction. Okay. An account has many transactions. Okay. So this kind of conceptual model. This is a typical conceptual model. Okay, where you will create the entities and probable relationship. Got it, Mahmood or Buddha, and anyone? Do you have any question, Firoz? Please ask me. Otherwise, I will move to now logical model. So once this model is being approved by the business, we'll move to logical data model. Let's start with logical data model. Please please open your this Accolade tool and start creating data model. Okay. Now open a. So let me do a on Snowflake or MS SQL Server. Let me open a MS SQL Server. Okay, underlying database is MS SQL Server, and I have opened this Hackerloid. Now I will start creating the logical data model. Okay, I have already created the conceptual model, which is my baseline for my logical data model. So from here, we will create uh, all these entities in our logical data model. So again, 8 entities will be created. Let us create 8 entities. Here, will in this tool, it is saying as a table. So don't confused. So in Arvin, you will see entities. Okay. Let's create the 8 uh, entities. 4, 5, 6, 7, 8. Okay. Placed here and there, and we'll rename all those. Now, what is the logical data model from conceptual data model? In conceptual data model, we have entities and relationship. So, Vishwa, can you tell me what is the logical data model? Anything, whatever you understand.
So here in the conceptual model, all that we're gonna define is like what entities are here in this in each entity. So what all the attributes we're gonna get into the picture here in the logical model, we're gonna define it.
Yes, logical in conceptual data model, it is just
Just entities, yeah, just on the top level of whatever
yeah,
we're gonna.
top level. But in logical data model, it will be more on technical side. All the probable relationship, we will create primary keys, we will create foreign keys, relationship, and also we'll define the attributes, all the attributes, whatever you need to provide to the business for this model. We'll define each and every attributes and the probable their data type as well. Okay. And which is null, also nullable, non-nullable, we will define. Means which column should be nullable one, which is not nullable one. All of those things will define here.
I mean, do we have any mention of the primary key or foreign key in this layer?
Yes, yes.
We have, right?
Yeah, yeah. We'll have those relationship, primary
So
key.
apart from the actual existence of the tables in the database, mostly in the logical one, we have everything, right?
Yeah, we have everything. Only the change in logical to physical is that physical under it will create similar thing with under it will take all the constant from underlying database. Say our database is MS SQL Server, okay, and it will create physical data model based on underlying your database. Like
Right,
it will
right.
just like in physical, say in MS SQL Server, this primary constant is there. Then we can create some indexing on some column. Okay. Uh, then we'll create partitioning if any. But in Snowflake, this primary key constraint is not there. There is a nullability constraint, right? So if our underlying table is Snowflake, then we'll create as per Snowflake. Okay.
Right. So basically, logical will be also database technology independent, right? Physical will be
Yeah,
technology.
This logical is technology independent. If we take this logical to any of your database, if we can take it to Snowflake, MS SQL Server, Oracle, MongoDB, any Hive, anywhere. Okay, we can we can take it. Okay, and we can. But when you will do the physical data model, if whatever the means database you choose, it will create according to that underlying database. Okay, your physical data model.
Right. Okay.
Okay, some of the database doesn't take, say, in integer we have integer, float, decimal, right? Three type of integers, three type of data type. Okay, some database do not consider float; they consider only integer and decimal. Okay, so in that database, that if even if you will create in logical model, if you give a data type float, it will convert it into decimal there. Okay, or integer, whatever. Somewhere integers are not there. You will see only numeric and decimal. These two data types are there. So in this way, you can see, you will see. I will do a MS SQL Server, then I will move it to Snowflake as well. Okay. same database. It's the same logical model. Okay. Now let's start to first. We'll start with the creation of all the entities. Okay. So first, first is the bank. Correct. So we'll create one entity called bank. Okay. What will be the uh, column name? Say bank ID. Also, in logical data model, we have to enforce naming convention as well. Say in for example, this bank ID, which is a primary key, and ID we are creating like bank underscore ID. So we can create like this as well, bank ID. Okay, but as here you create bank ID in say branch, you are writing branch underscore ID. You should we should be uh, uh, we should follow the naming convention of that organization. What in as mentioned in a data architectural document. Okay, so we need to uh, enforce the naming convention. This is the best practice. Okay, one of the best practice in data model. Okay, enforcing the naming convention. Like so when we do dimensional model, how we will understand which one is dimension, which one is fact. Correct. We will follow some say naming convention. Okay. So our naming convention is that whenever there is a ID, we will create underscore an ID. Okay. So this is our naming convention, and this is since it is an ID, we'll and we'll make it a primary key. Data type integer. On here, see, since I moved from Snowflake earlier in Snowflake, we can see data type as a integer, then other things. But in SQL Server, we can see it is a numeric. Okay, and in data here we cannot see the primary key. 1 second, please. Why we are not able to see it?
You have unique there, unique. You see.
But there should be a primary key, like, and okay, let me check one more table. Say branch. We have branch code for branch ID. Say like branch code. Okay, and then we have a bank ID. I think I'm getting bank ID, which is an integer. Okay. Foreign key table is branch. String name is branch ID. Okay. Here we have to create non-nullable and unique. Okay. Okay. We have created two entities, one branch and another one is bank, another one is branch. So in our branch step, in our branch, we have two column two attributes. One is branch code and branch ID, and this branch ID is coming from bank, which is relation is one to many. We have created this one to many relationship. Now, third one is a branch manager. Okay. Then first create employee table. Better to create an employee table first. We create employee. Are you also doing similarly? If you are not on mobile, if you are on laptop, are you also doing the hands-on? Which one?
Maybe I have to switch the tabs because I'm using the same laptop.
Okay, okay. So please do
Yeah.
that. Okay. Otherwise, or if you are not doing now, if you are looking into the this how we are creating, please do once this session is over, before tomorrow's session. Okay. So we'll have employee ID, then we'll have employee name, then say gender as of now. Okay. We get employee ID as a primary key, unique, and we'll create as a numeric. Okay. Then we'll have branch manager. Branch manager. What we'll have first? Branch manager ID. Let me write first. Editor. Also, guys, one more thing. If you have any model with you and you want to create a logical data model, say for relational model, please bring that. We'll also do, uh, means we'll not go so detailed, but we'll do that. Okay. Mahmood, I think you have something in your mind for relational model or dimensional model. You are talking about, I think, dimensional model, right?
Yeah.
So we'll take that your use case tomorrow, and we'll create a dimensional model out of that. Okay. Okay. As of now, let me complete this one. Branch manager ID, which is a primary key. Then in branch manager, what we'll have? Employee ID, which is coming from uh, employee table. Okay. Employee ID, which is a numeric. Then we'll have in branch, we'll have what we'll have. Branch manager is also related to branch with the branch code. Branch code, which is also integer. Okay. And what we'll have in branch manager, we'll see that to maintain the history, we'll have start date and end date. Correct? Because we did here start date and end date for branch manager. So we'll create here also start date and end date. Okay. Now we'll create a relationship between these two. Okay. This relation is what relation? This relation is we'll name as um, employee and branch manager. EMP slash branch manager, BM. Okay. And what is the kind of parent table will be employee? Okay. What is the field name in employee? Employee ID. And child table will be branch manager. What is the column, it is employee ID. Cardinality is 0 to many, means an employee can become a branch manager, may or may not become a branch manager. Okay. And but branch manager is always an employee. Okay. So this is the cardinality. And similarly, in from branch to branch manager. Okay. Again, we will create one more relationship. Say this is branch, yes, branch. Name of the relationship is branch to branch manager. Okay. And what is the child table here? It is parent table is a branch. Parent field is branch code. Child table is my branch manager. Child field is okay. 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 So this relationship also created. Now we'll create one supervisor. Let me save this. I think I will close anytime what I am doing. Supervisor. Then guys, one more thing. I will provide you few more use case after once our session is over. It doesn't mean that our communication will get over. I will give you more use case to you. You create that use case and send to me. Okay, I will check and give the feedback. And if you want to discuss, we can have one discussion. Okay, on that. But it will not be too long. A short discussion. It is okay. I will give you use case after this. This is a simple thing which I am creating. I will give some more use case to you. You will in your off time, you create the model and send me, and I will show you how to send the model so that I can open in my Hackolate tool and I can see your model. Okay.
Yeah, to him, one quick question here. The manager ID is going to be something like a sequential key or something.
Yes, I have created key, right? See, here key means star.
Yeah, no, I mean to say something that is going to be like changing each and every time, like something like a sequential key, right?
Yeah. Branch manager ID is a sequential key.
Yeah, okay, gotcha.
In supervisor table, we'll have supervisor ID or manager ID, whatever. One second. Then we'll have employee ID. Then in supervisor, also we'll have uh, start date and end date. Okay, we'll create one start date and end date. And end date. So how you will create one more column here? Just click on this entity, and here you can see in the left hand canvas, add. It will add one more column here. Okay, in this way you can do that. And now I am deleting this one. Okay, this is also integer. Now relationship between the supervisor ID is also a employee. Okay, so the foreign key foreign table is a employee table, and foreign field is the employee ID. Supervisor ID is nothing but a employee. Similarly, there's a relationship between employee and employee ID. So if we go to this employee ID, again, we can create a foreign table is an employee, and foreign field is employee ID and employee. So they will become two relationship. Okay. And what is the primary key of this table? Supervisor. We will create a composite key because supervisor ID, employee ID, and start date will become a composite key. Okay. Combination of this start date. Once again. Did you get me? Supervisor ID, start date, and employee date. These three become my composite key and composite primary key. Okay, why so? Because see here. Now, say supervisor, if I create a primary key on supervisor ID, see it is not matching because two supervisor ID, we have more than one supervisor ID. It is not uniquely identifying one record, right? If we create on combination of these two, okay, it will also not feasible because see now it is feasible. Okay, if we combine supervisor ID and employee ID, it will become a if say supervisor is 002 and 1003, it create a unique record. Okay, but say if I create say start date from say 12th of August 2023, he's a supervisor. This 1002 is a supervisor of 1003. So after that, 1003 will have new supervisor, say who become say 1001 become his supervisor ID. Okay, from say 31st, here is 31st 12 2023. Okay, now from 1st of January, 1st of Jan 2024, he become the supervisor of this employee. 1003 means Mahmood. Mahmood is you are you are changing your supervisor. Say first your supervisor is this one. Now understand this one logic. Otherwise you will not get it. Why I make these three as a primary key. Okay. Now now what happened? This Mahmood also again now change his supervisor to Firoz. Okay, and not Firoz. Sorry. So from 12th to 31st, his supervisor ID Mahmood's supervisor was Fahad, and from 1st Jan, Mahmood's supervisor was Buddhu. But it happened that Farad again become his supervisor. Say on 30th June, from 1st July, again Farad become his supervisor. Say for it might happen, right? In this typical business, it may happen. A company that again same supervisor you can encounter. Okay, so again he become a supervisor. So if I create the combination of these two, say start date and end date is not there, this combination of these two, then this will not uniquely identify my record, right? Because again, same pair of supervisor ID and employee ID can come into picture, right? If I combine these three, it will become uniquely identified. Say 1002 supervisor ID, employee ID is 103, start date is 12th August. But here again, say 1002, employee ID 103, the start date is 1st of July. Okay, so in this way we can uniquely identify the record. So that's why I have created supervisor ID, employee ID, and start date as my unique. So guys, again I said during model you have to create some dummy record, or you have to check the source system to understand how data is coming. Okay, without that, this, if I have not done this, I have not shown you this requirement, this kind of data, means how data is coming or business requirement, then our model is wrong, right? If I not created these three as a my uh, primary key, composite primary key, if I keep these two as a combination of these two, but primary key, then when we run into means when it is deployed in the database and actual data will come, it will fail, right? Data will not get loaded because it will what it will that this primary key constant is not met, so job will fail, your ETL job will fail, correct? So that's why we have to create a scenario, we have to make lot of Excel, lot of dummy record to understand how business scenario can with means can handle this handle this table. Okay, so here you can easily see that if we combine these three column into composite key, it will handle my uh, this table, this entity. Okay, and it can handle the when we load tables with actual data, it will with means it will stand still. Okay,
So, Tuhin,
any question? Yeah, tell me.
so we can understand it like, with the supervisor, we have identified the grain at supervisor ID, employee ID, and the start date level, right?
Yes, yeah.
And if in future, Tuhin, if there is any business requirement change, they want to add some extra column, right? In future,
Hmm.
so how we can handle those things, and that column also might be required to play a role where it is the unique column, right? Maybe the primary key. It is also face. Do we have such cases like if in future if business added two, three more column, and with that column combination, we also need to identify the unique key, right?
Yeah,
So
yeah. So if we, that means your business scenario got changed, right?
yeah,
You have to refine your model. Then you have to again go back to your relational model, and you have to change that and see how it get impacted to other entities. If you change one entity, it is affected to other. You have to
yeah.
that, and also downstream and downstream means where it is flowing. Your model is being flowed to another. Another model is referring to your model. Then it is that model also will have some changes, right? Uh, uh, so that is a it is not that will not be done in one day. You have to do impact analysis, you have to check how we can handle that. Okay, and then we need to change it. So for earlier, this scenario is not there. Say, simple scenario for example, the supervisor table. Okay, my scenario is that on a and supervisor, you cannot have a repetitive supervisor. Say एक बार हो गया तो हो गया बस खत्म. You cannot become his supervisor again. Okay, then might this start date might not be needed, right? So in this case, this record will not come because 1002 already become a supervisor of 1003 here in this column. So if this supervisor needs to change for 1003 for Mahmood, maybe somebody else say Syam or may other guys will become supervisor. Okay, if that is the scenario, then my start date might not be my primary key. But in future, my requirement change and it become that you can have repetitive supervisor, just like you said, my new functionality added or new thing added, okay, column added. Then here now we have to make this also as a primary key, composite primary key. Okay, so that time what it is not that you make just change the table and make a primary key. The whole things will be change. Many things can be changed, so you have to check the impact, how it is getting impact, how whether the supervisor in this supervisor table will be is being used in any other in any other application or not, on how they are handling that, means how they are handling, means from here they are creating something else, okay, some other tables or some application, front end application, how they are taking data from here. So you have to check that as an architect. You have to look into that one. You have to talk to say from here there is a front end application which is built on Java, and it is taking data from supervisor table. Okay, you have to check with Java people how they are handling that, and how if you change this as a primary key again, how they will handle that one. Okay, so you that need to be discussed, and then only you can change it. Okay.
Okay. Okay.
Okay, let's move on. So we have created so many tables. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, 9
So,
tables.
like one quick question over here. So, same can be the same scenario can be made with the branch manager as well, right?
Yes.
So, if employee ID and employee ID, if the same employee is coming as a manager for the branch again after some years, so it's gonna be the same case, right? So employee ID,
Yes.
branch code, and start date can be made.
Yes.
Okay.
Yes. Here, as of now, yes. Good, Vishwa. Same here. Only we are creating branch manager ID as a front key. Okay, here it will not hamper so much, because this branch ID, whenever new branch is coming, a branch manager is coming, we are giving them a new branch ID. Okay, see,
Yeah.
if similar employees coming to same branch as a new branch, as a new branch manager, then also his branch manager ID will get changed. Say earlier it was say 1, 2, 3, 4. Now he's working in same branch. Okay, same employee coming say after 5 years, his branch manager ID will change from say 1, 2, 3, 6, like that.
Yes.
It will
Yes.
not
Yeah.
hamper such. Suppose
Yeah.
if branch manager ID is not there, this column is not there, or this entity, this attribute is not there. We have employee branch, and then we have to create. Similarly, for supervisor, we have to create a composite key of employee ID, branch code, and start date. Correct, Vishwa? Since we are
Yes. Yes.
creating a branch manager ID, it will not hamper. But yes, if and also if same एक बार branch manager, if you become a branch manager, your branch manager ID is uh, then there will be another ID, branch manager, and it will remain same for whole, means wherever you are going. Then that case again we have to create the start date as a composite key. Okay. Okay. So it is based on the scenario which we are uh, going to do. Okay, going to cater. Okay. Now move. Let's move on, because we have very less time left. Now we'll create one column call. Here we'll create one more entity called customer. Okay, and my uh, my business key is the customer ID. Sorry, primary key. Okay, then which is a primary key. Make it integer. We are making primary key as an integer. It is not mandatory that you have to create primary key as an integer. It might be varchar, but I for this model we are creating that. Okay. Then we have, say, customer name. Bishwa, please be attentive. I will resolve one of your question last week. You have asked me loop of relationship, right? I will, I
Yes.
will,
Yeah.
I will cater this one here. I will see. I will show you how loop of relationship. I will remove the loop of relationship here. Okay. Say address, customer address. Okay. I have given few. There are many. We can give many things, but I have given. Say, let me give one more column. Say email ID and phone number. Two more columns. Email ID and phone number. Mobile number. Okay. Is a customer. Then we'll have account. In account, we'll have an account number, which is my integer, and it is a not my unique. Okay. Then in account, say in our requirement, you remember we have requirement is that account can be a savings account or current account. So in account, I have account type, correct, to identify whether it is a savings account or current account in our requirement. Okay. Then we'll have in account, what else we'll have? Customer details, like customer ID means this account belongs to which customer. Okay. So customer ID will be there. And also in account, we have a requirement like that. You remember, if an account is always open a specific branch, so our account will have a branch code as well. Yes.
Branch code, open date,
Yeah.
others,
Yeah.
like transaction date, like kind of.
No, transaction date will not have in account. That will be transaction table. Okay.
Okay.
Branch code. So typically account means if you have
Balance, we can have balance, right?
no. That is we'll also have in a transaction table.
Okay.
Whenever Mahmood, you have seen a passbook of any typical branch bank like SBI or
Yeah,
HDFC.
yeah.
The first page of your passbook
Mhm.
is actually the account information where you'll have account number, customer ID, customer name, and all those details, right?
Mhm.
But the transaction is in a subsequent inside the page which is being this account means first page is not being changed, right? But your transaction is getting inserted. Okay. So that's why we'll have all this. Say yes, one more we can add here. Open account open date. Okay. Now we have to create a relationship. Okay. So customer ID. What is our relationship with account with customer? A customer can open a multiple accounts. So one to many relationship. So we'll create one relationship which is uh, cust to account. What is the relationship? Parent table is my customer. Parent column is customer ID, and child is my account. Child column is okay. Here it is. I have written haircare, but here it is an integer, so we have to change it. See, otherwise your data type should be similar. Otherwise, you cannot uh, connect it. Okay. Account. It is customer Okay, it is a customer has in an account. Can a customer have many one or many accounts? Okay, and a account should have at least one customer, so it is one. Okay, similarly between branch account, what a branch account is open in a specific branch. It is an account is relationship with account to branch is one, but branch can have many accounts. So in a branch there are many accounts. Okay, so it is one to many. Okay, again we will create one relationship here. It is a account with branch. Which is my parent here. Branch is my parent. What is the field? Branch code. And child is my account. And column will be again I made the mistake. Here it should be an integer. Okay. Not it is not 0. Should be 1. Okay. Okay. See here the check here cardinality. Here I have made a branch is open into a specific branch. So here at least one. But here I make it 0 or many. Why? Suppose a new branch is open just today and there's no account yet open. Nobody came here. Okay. So a branch can have 0, 1 or many accounts. Okay. So newly opened branch can have a 0 account. Okay. So that's why it is 0 or many. Okay. Now last table is a transaction table. Okay. We'll create a transaction table. Okay. First will be my transaction number. Whenever there's a transaction is going on, we'll create one transaction number, which is a integer. It is a unique, not nullable. Okay. Now, in transaction table, what we'll have means from which account my transaction has been done. So I will have some account number, right? Which is integer. Then which customer has that transaction? Then we'll have a customer
Why
ID.
you are why you are using like in account you have account NO, here you are using number.
Oh, yeah, I will
Yeah.
tell you. Yes.
Yeah.
Very, very good. Very good. I am not following naming convention. Let me change it. Very good. Okay. Then we'll have in transaction table what we'll have more. We'll have say transaction type means what is transaction type, like whether it is withdrawal or deposit, right? Transaction type. And then transaction date means when that transaction happened. Transaction date. So what is the relationship? Yeah.
Amount.
Huh? Amount.
Amount.
Yes. Yes. That is the most important amount. Yeah. Now we have to create a relationship between account and transaction. So what is the relationship? An account can have 0 or 1 or many, correct? So the relationship will be 0 or many. Correct? An account can create a transaction or may not create a transaction. Okay. So, but what is the relationship from transaction to account? Whenever there is a transaction happened, it should be have one account number. Otherwise, I will understand who has did that transaction, right? Okay. So relationship will be like this for account and transaction. Say account, between account and transaction. My foreign key parent table is account, parent field is account number, child table is transaction, is account number, zero or many. Okay, so let me change this as well. So you understand, account can have one, or it can have zero or many transaction, can may or may not do a transaction. Okay, but transaction should have at least should be done through an account. Okay, so account number should be there. Okay, similarly a customer can do a transaction. Okay, do may or may not. Okay, may not do a transaction. So what I will do, I will create one more relationship here. It is between customer and transaction. Okay. Relationship parent table will be my customer, customer ID. Child table will be transaction, customer ID. It is 0 to many. So whenever a customer can do, may or may not do a transaction, zero transaction or many transaction. Similarly, whenever transaction is happen, there should be a customer ID. Okay, let me save this one. Okay. Now, now I will ask few questions. So our model is ready. And before I ask any question, anybody has any question till now? Anyone? Mahmood, Vishwa, Firoz, Buddha, Farad.
So, Tuhin, I have a question. Maybe it might not be correct at this level. Maybe it is more pertinent for physical data modeling. My question is like, just before you started this one logical one, so you said for this particular tool, the interface, I would say, like the interface for logical and physical is kind of same, right? So how we will actually know that this is logical and something else will be physical?
Yeah, in this tool you cannot see that, but in Arwin or YA Studio,
right. That's why
there's a block down and there's some drop down structure is there,
yes,
where
right.
you have a logical data model, and then you can see a physical data model. Okay, and in a schema you will have two schema for logical data model and another is physical.
Right. Yes.
And also only when you can see the physical if you forward engineering this one. Okay, once this model is logical model is done, you have to make a forward engineering so that your
details will be created and you can get the physical one.
This one. Okay.
Got it. Yeah.
But here this is the free tool and we do not have that functionality. Okay, so we cannot see that one.
So in the registered version of Hackolight, we have that option?
I do not know that one.
Okay.
I think no. It has only one interface where you have to do both physical and logical data model.
Got it. Perfect. No problem. Yeah. Thank you. Thanks for
And
that.
it is not typically used anywhere. This
Right.
Never seen any company is using this tool. But for practice, we are creating. But but when in actual project, you will encounter a good tool like Erwin or or say
We
yeah,
used one thing, na, that IBM Studio, something we used in one of our projects.
yeah, IBM Infosphere Data Architect tool,
Data architect, right.
IDA. And also there's one more tool, web version tool is called SQL DBM. Have you heard this one? Anybody? SQL DBM?
Yes, yes, yes. Doing I have used.
Yeah, that is also a good tool. Okay. So there also you can do a logical to physical determinism. It will change. SQL DBM is very good. It is colorful tool. I like that tool. If we go for that free version, it again give me only one interface. That is a logical or physical one. It will not give us full one. Otherwise, we need to pay. Okay. Anyway, let me show this one. In your actual project, if you are using Irwin or Studio or SQL DBM, you may practice there and remove. You may practice for your in that tool. You will see all those. Okay. Any question apart from that, Buddha or anybody? Why it is giving head?
No, I'm good.
See, it is giving me some error here. It is saying that name validation is not satisfied. I have given here,
Hyphen, yeah.
yeah, hyphen. It should be underscore. Okay. Okay. So my model is created. What say this is a logical model. If I want to create into database, I will do what? I will see here in the below there is called DDL script. If I click it, it will create a DDL script for MS SQL Server, and I have to copy this one and paste into our in our SQL Server to create the tables, and then we'll start with our ETL job to load this. Okay, but here we have one flaws. Okay, not flaw. It is called relational loop. Have you heard this term? Anybody? Apart from Vishwa, anybody have you heard this term? Relational loop.
No.
Okay. So actually,
So, Putin, is it like when you have a kind of a transitivity in the relation, in the data, right? So maybe that's
no,
when you,
no, Buddha. It is a relational loop is where we are looping a relation. Okay. Uh, this question this thing actually highlighted by Vishwa. He pinged me one day and asking about relational loop, which I said I gave him the answer, but I said that when I will do the practical, I'll show you the relational loop and how to remove that relational loop. So during our challenges and best practices, I told you last week that issue is that we are creating unnecessary entities or relationship, correct, which is not required. So similarly entity not only entities, relationship is also an object which is we are creating unnecessary. Okay, some relation is not required. Okay, not required, suppose and it we can easily remove that relationship. Okay, so this is called relational loop. Loop means when we are looping a relationship and we can remove one relationship, then also my model will exist. That process is called relational loop, and we need to remove that relational loop. Let me show you. See, here in our, please pay attention here. Okay, uh, we have three. I will say now column. Say now this is my physical model. I will say column. Sorry, tables and column. We have three, or anyway, we logical model will say entity and attributes. We have three tables: account, customer, and transaction. See here, looping is that account is looped to customer, account is related to customer, and account is related to transaction. Again, transaction is also related to customer. There you can see there's a loop, kind of something looping of each and everything is being related to everybody. Okay, suppose now I have to remove this relationship because this relationship is not required. A is related to B, B is related to C, C is related to A. I do not require. If A is related to B, B is related to C, that means C is always be related to A. Okay. Suppose if I remove this relationship, I am removing this relationship, this customer and transaction, and I am removing this column or this attributes. Okay. See, my looping of relations is removed. Okay. If I know the account number, I can easily track the customer. Who is the customer? Do I need in transaction? Do you need the customer ID? No. In actual scenario also, if you see in a transaction, there is only account number is mentioned, no customer ID is mentioned, right? So this is the removal of a relational loop. Understood, Vishwa? I have removed the relation, and I have also
Yeah,
removed
yeah, got it, got it.
column. My object is reduced. I have optimized my model. Okay. This is called removing of loop, relational loop. And now my model become more refined. If we know the account, we can easily track the customer. Correct? Say if this transaction is done by account number 1234. I will go to account table and find account number 1234 belongs to which customer. Correct? No need for that relation, and no need for my extra attributes in transaction tables. Okay. So have you understood? Any question, guys? Mahmood, Farad, Guddu?
I think it's
Suppose we still have
Hmm.
the column. I don't want to remove it. So is there any other way to resolve this issue?
No, I do see. Say Mahmood, we are creating model. We need to make a optimized model. Why I will create unnecessary column into a table, or it will just overload my transaction table, right? My one column will add. It has no value to me. If I know the account number, I can easily find out the customer. Correct. Why to overload that? This is called optimization of your model. It will overload your ETL process. You have to load that. Any column which is written here, there should be an ETL process to load that column from the source, right? It is overburden on ETL process as well. In ETL, you have to join something and create the customer ID or like that. Okay, no need for
The tool itself can't can't give us any idea that something is going wrong.
no. Tools will not give you whatever you tell the tool. See, I have created that relationship which I have removed. Okay, tool is not giving me any issue for that because that is not an issue. That is still exists. If I can, I do not know whether I can. Okay, I can make it reverse. Okay.
We need some artificial intelligence to in this.
I think Copilot nowadays are linking. Like if
Yes.
you use DBT Copilot, if you mistakenly write anything and it's not linking to the correct scenario, it will automatically give you error message. I think he is referring to that kind of thing.
No, but in till now, there is no co-pilot or AI kind of things in data modeling tool they have incorporated. Okay, and see, so this
I
is
think
not
it's not
a
a issue. I think it's a
yeah,
best
this is not an
practice. Yeah.
issue. This is a something looping of relationship. There is if you create like this, there is no issue. It is 100% correct model. But what I say, Mahmood or Farad, it is about a optimized of your model, optimization.
I
Okay.
think in order to avoid the join complexity as well, right? Why you are necessarily joining one more time with
Correct.
transaction to the customer based on the customer ID level, right? If you
Correct.
already know the details of the account number, as you mentioned, right? So
Yeah.
account number, we can backtrack and get the details of the customer. So it will make the performance also much faster. Suppose if the customer table is very big, right? And you're joining with this table. So unnecessary, it has to scan the full table and then get the matching data. So I think that scenario also optimal performance wise also this would be the best in terms of data retrieval as well.
Correct, correct, Farad. I already said that it will overburden on ETL process, right? It will remove that burden on ETL process. So if we remove this looping of relationship, it will remove the burden. Okay, unnecessary. See, this transaction table is also become, if my transaction table is very big, and this customer ID is also populating and it is giving some loading on your ETL process. So if it is a cloud environment, everything on your compute, right? And it is on-prem, then why I will create this extra redundant data here, right? It is on-prem, then no need to create an extra redundant data, because transaction table is typically very big, large table, right? Why I will create this one? And if it is your online, cloud system, then why I will give unnecessary compute to ETL process? Cost estimate. So you have to do, as an architect, you have to know the costing or estimation of cost as well, right? Not only you create your model such that it will give less cost optimization, and no artificial intelligence will tell you to remove this, because this is not a incorrect, this is a 100% correct model. But concept experience will saying that remove this one. Okay, remove this one, remove this one. Okay, now your model become more what I say, more refined. Okay, more optimized. Okay.
So it's not only override to ETL, it's also part of reporting as well. You will do it join and serve doing and out. To create a report also, it will create override on that.
Yeah. And it is looking more nice as well, right? It is only you are getting 8 entities. So in typical relation model, you have thousands of entities, right? My model is getting more slimmer, more beautiful as well, beautification also. Okay, readable, easily trackable. Okay, all this your model, you can make your model look more refined, optimized, whatever the definition word I say. Okay, so so any question on relational model? Today I will just go through few basic of dimensional model, and tomorrow we'll do dimensional modeling exercise. And I got few requests from few of you to create a dimensional model on sales table. So I have created one uh, use case which I will discuss tomorrow for sales thing. Okay. So any question on relation model as of now, from modeling perspective, from any question, any theoretical, practical question? So I think you are okay with relational model. So in future, whenever anything is being asked on relational model, uh, you can create as of means
I mean,
as taking.
I got, I mean, some good idea. I mean,
Yes, Mahmood.
but yeah, but working in, I mean, real work is something different. But I got, yeah, from my
Yeah,
previous
real,
knowledge, I got, yeah,
yeah,
I'm in a
real
better
world,
shape.
yeah, real project and demonstration or this instruction lead training is always different. I cannot bring my real project here, correct? But Okay. See here, I can think one question which I was expecting from you guys. Uh, let me tell that question. Because between this account and customer relationship. So nowadays, or in typically in every brand, in every bank, an account can be created is being opened by multiple customer, right? It's a joint account. So in an account, there will be two customers, correct? Say Buddho and his wife has opened an account. Okay. So in that account, we have two customer ID because one for Buddho and one for his spouse. Okay. Uh, so here the relation become many to many, correct? An account is opened by many customer and an customer can open a many account. So how we'll handle that one, that scenario? So now in my scenario is that an
But
account is opened by only one customer. So now I added one question is that an account can be opened by multiple customer like joint
one,
account.
one, the there'll be like first customer, a second customer,
Hmm.
one main customer, like that.
Yeah, one primary customer, one secondary customer. Again, say open by three customer, one primary customer, two secondary customers.
So Tuhin, your question is that if we have many to many relationship,
Yeah.
like in this case, so how we can tackle this
Hmm.
scenario?
Hmm.
So I think we can introduce the bridge table over here, right?
Correct. Correct.
Yeah.
This is what I
With
want.
with adding the key columns in order to get the details to avoid the many to many relationship.
Correct.
Bridge table will.
Yes. In that scenario, we'll introduce here one more table called bridge table where we'll have account and customer information. And here, then account to that bridge table will become one to many, then many to one, like that. To avoid this many to many relationship, we can do that. Yes. That is what I want to know. Thank you, Fahad. So nothing else. Any other question, guys? Okay. Now, I on your requirement, Mahmood.